In this question, we're given the first 5 terms of a sequence. We're asked to find an expression in terms of n for the nth term of this sequence. So we can start by rewriting out the sequence below. Now the first thing that we're going to do is to calculate the difference between the terms in the sequence. The difference between 4 and 11 is 7. The difference between 11 and 22 is 11. The difference between 22 and 37 is 15. And the difference between 37 and 56 is 19. Now we can see that this isn't a linear sequence, because the differences between the terms of the sequence are not equal. But now what we can do is to find the second difference, which is the difference between the differences between the terms in the sequence. And so we'll find the second difference in green. The difference between 11 and 7 is equal to 4. The difference between 11 and 15 is equal to 4. And the difference between 19 and 15 is also equal to 4. And now since our sequence has a constant second difference of 4, we can say that it is a quadratic sequence. And a quadratic sequence is written in the form an squared plus bn plus c. And so in order to find the nth term of the sequence, we need to find the value of a, the value of b, and the value of c. To find the value of a, we find half of the second difference. The second difference is equal to 4. And so we can say that a is equal to 4 divided by 2, which is equal to 2. Now that we found a, we know that the nth term of the sequence is 2n squared plus bn plus c. And now to find c, we need to find the 0th term of the sequence. We know that 4 is the first term of the sequence, so we can say that this term is number 1, number 2, 3, 4, and 5. Now since c is a 0th term, we need to work backwards in order to find the number that goes over here. We know that the second difference is equal to 4, so we can do 7 take away 4, which is equal to 3. Now that we know that the first difference is equal to 3, we can say that the 0th term is equal to 4 take away 3, which is equal to 1. So far, we found that a equals 2 and that c equals 1. Now to find b, we need to substitute in a value of this sequence. So now let's take a look at when n is equal to 1. When n is equal to 1, the value of the sequence is equal to 4. So now we can use this information to find the value of b. We know that a is 2, so 2n squared, but we said n equals 1, so 2 multiplied by 1 squared plus bn, well n is equal to 1, so that's c plus b, and we said that c is equal to 1 equals 4, which is the first term of the sequence. So simplifying this, we have 2 plus b plus 1, so we have 3 plus b equals 4, and therefore we can say that b is equal to 4 take away 3, which is equal to 1. Now when we substitute these values into the format an squared plus bn plus c, we can see that the expression of the nth term of the sequence is equal to 2n squared plus n plus 1. Now this question is worth 3 marks, so let's take a look at where these marks are allocated. Now the first mark is for a correct start to a method to find the nth term. And so we started this by finding the second difference of 4 and dividing this value by 2 in order to find the coefficient of n squared. And so we said that the value of a is equal to 2. And now the second mark is for finding either b or for finding c. And so we did both very clearly. And so we'll get that second mark for either showing working out to find the value of c, which is equal to 1, or the value of b, which is also equal to 1. And now the third and final mark is for getting the correct answer of 2n squared plus n plus 1, allowing us to get the full 3 marks needed for this question.